this is worksheet 1 of the atomic structure packet. As the name would suggest, this whole packet is going to be learning in more detail about all the different parts that make up an atom and being able to describe atoms of different elements in more detail than we have so far. A big part of this packet is going to be learning how to represent atoms. Atoms are sometimes challenging for us to learn about and think about and talk about because they're too small for us to see, even with a really strong microscope. And so we have different representations, different drawings that we learn how to make so that we can communicate with other people about atoms and represent them. So the first diagram that we'll learn how to make, you're going to learn in this worksheet. It's called a Bohr diagram. In later worksheets, we will also learn how to make something called an electron configuration, and then near the end of this packet, we will learn how to make a Lewis dot diagram. But all of these different diagrams are trying to represent an atom, and they all have their pros and their cons. None of them are a perfect representation of what an atom really looks like. This Bohr diagram that we'll start with today is going to be the most basic. It's like the stick figure equivalent of an atom, right? When you're trying to represent a person, a lot of times you'll just draw a stick figure. And we all know that a person doesn't really look like a stick figure, but sometimes for your purposes, drawing a stick figure is enough to represent what you're trying to show. Look, there's a person here. Look, there's another person over there, right? And it's a heck of a lot easier and takes less skill and time than trying to draw a perfect portrait of somebody each time. All right, so keep that in mind. This isn't exactly what an atom looks like, but sometimes it's enough for our purposes. Okay, so you are going to be expected to go through and fill in this diagram up at the top that should look very familiar and is just reminding you that you can't forget what you learned in the last packet. So if you already have, you're going to have to pull out your periodic table packet and get this filled in, but hopefully it looks pretty familiar. Okay, so make sure you go back and do that, or pause the video now and do that before you go on. Okay, next we'll talk about the Bohr diagram though. Okay, so the Bohr diagram really focuses on electrons, right? So we know that electrons can be found sort of circling or moving around the nucleus of an atom, and we can find them in these areas that may be close or far away from the nucleus. And so we call those spaces or those locations energy levels or shells because we represent them very basically with these little circles. Okay, so this guy Bohr, who hopefully sounds familiar to you from your atomic timeline project, came up with this idea that we could represent each one of these energy levels with capital letters. He started with K. I have no idea why. That was the lowest energy level, so that's the energy level that's closest to the nucleus. And then he went alphabetically from there, L, M, N, so on and so forth. Okay, so the thing is that electrons are negative, and opposites attract, but like things repel. And so these negative electrons, right, they repel each other. And so there's only so many that you can fit into a certain energy level or a certain space. So Bohr had this sort of mathematical equation that you don't have to worry about using. I'll never ask you to calculate it, but I don't want you to think I'm just making these numbers of electrons up. It was 2n squared. So he said, okay, if K is the first energy level, right, we'll plug in 1 first for n, and 2 times 1 squared using this formula, right, gives us 2, okay? So the first energy level, the first shell around the nucleus, can hold 2 electrons maximum. Great. Okay, so then the L shell, the next shell out, a little bit further away from the nucleus, it's the second energy level, right? So we'll plug in a little 2 into that formula, and we get that it can hold 8 electrons, and so on and so forth, and this actually, it works. Okay? And so we make this diagram, this Bohr diagram, that has a couple different parts. It has a circle, okay, so if you look down here, this is just like a really generic, general sort of formula for making one of these, right? So when you make a Bohr diagram, you're always going to make a circle that represents the nucleus, and you're going to write in that circle the number of protons and the number of neutrons that that particular element has. Okay, so if we look over here, here's an example. Let's say I asked you to make a Bohr diagram of phosphorus, right? You'd draw this circle that's going to represent phosphorus's nucleus, and you'd say, all right, well, I know from looking at the periodic table that phosphorus has 15 protons. So you'd write a little 15p here. And I know if I subtract the mass minus the atomic number, the two numbers that are on the little square on the periodic table, right? 31 minus 15 in this case would give me 16, so I have 16 neutrons, okay? So there they are, protons and neutrons are found in this little circle that represents the nucleus. And then you start worrying about your electrons, right? So we're assuming, I told you there will be an exception later on, but for now that the number of electrons that an atom has is equal to the number of protons. Okay, so whatever the number of protons is, that's how many electrons you're going to have. But the electrons aren't found in the nucleus. They're found in these shells that go all the way around the nucleus. Okay, so what we're going to do is we're just going to make little like half circles here to represent those shells. Okay, in reality, the shells would go all the way around the nucleus, but that's really big and bulky to try to draw each time. It takes a bunch of space on the paper. So we just make, let me get my eraser, these little half shells. Okay? All right. And then I say, okay, well, in that first shell, that would be the K shell, right? Okay, I'm going to actually kind of fill this in down here. We'll keep track. The first 4 energy levels. Okay, well, the first energy level we call the K shell. Okay, and we looked up here and we saw, and if we use the formula, we could do that too, that it can hold 2 electrons. I'm just going to put E there. Okay, so that's what this general diagram is representing here, that this can hold a maximum of 2 electrons. Okay, so for phosphorus, so over my example, I got 15 electrons I got to place. The first 2, right, I'm going to write 2E here, go in the first shell, and then that shell's full. I can't fit any more electrons in there, because that first shell, it's kind of small. It doesn't take up a lot of space to go around the nucleus once, real tight in close to the nucleus. Okay, so then I'm going to draw another line that's going to represent my L shell. Okay, and my L shell, it's set up here, can hold a total of 8 electrons. I'm going to make a little note of that. We're making these little notes so we can refer back to this later when you make more Bohr diagrams. Okay, so I'm going to put my next 8 electrons in the L shell. Okay, so let's look at our example. I've put 2 of the 15 total electrons that phosphorus has in the K shell. I can put up to 8 more in the L shell. All right, so that means right now I've got 2 here, I've got 8 here. I've placed a total of 10 electrons so far. All right, which means I got 5 more left since I got to add up to 15 for phosphorus. Okay, well, that means I'm going to have to open up another shell. I'm going to have to open up the M shell. Now, if we look over here at our general diagram, the M shell, it says, can hold a total of 18 electrons. Okay? Now, really important point. Why did I not put 18 electrons in my example of phosphorus? Think about that. That's pretty important you understand, right? It's because the M shell can hold up to 18 electrons. It's got room for that many, but remember, we're drawing a Bohr diagram, in this case, not of just any general atom, but of phosphorus, which has a total of 15 electrons. Well, I put 2 here, I put 8 here, that's 10. I only had 5 left to go in the M shell. Okay, so the M shell could hold more, but phosphorus doesn't have any more to put there. All right, cool. So the thing is, there's an N shell also that can hold 32 electrons. I'm really not going to ever ask you to draw Bohr diagrams for atoms that have that many electrons. Okay, but you are going to want to memorize. So the sooner you do it, the easier your life will be. You do want to memorize that the K shell, the first shell, can hold 2 electrons. The L shell, the second shell, can hold 8 electrons. And you could memorize that the M shell can hold 18 electrons, but honestly, you'll never have an example that you have to draw where there's even 18. So pretty much just the rest of your atoms that you have left over for your purposes are going to go in the M shell. Okay? All right. All right, so it asks you what is the general equation that we use to figure out that 2 could go in the first shell and 8 in the second shell and so on and so forth. It's 2n squared. Again, don't get all scared that I'm going to make you do a calculation with that. I'm not going to. All right, so we're going to do an example here of a Bohr diagram for hydrogen, because hydrogen's really sort of a funny one. Sometimes it throws people off because it's so little that it's almost like harder to draw because there's just so little going on. So for hydrogen, what I'm going to do is I'm going to draw its symbol first. You don't want to forget that. Okay, so if I look at the periodic table, hydrogen has a mass number of 1, and it also has an atomic number of 1, which is weird. They're the same. Okay. Then I'm going to draw its nucleus, and because its atomic number is 1, it's got 1 proton, and this is the really weird thing. Remember, the mass minus the atomic number in this case gives us 0 neutrons. It's the only one that's like that. Okay. And then I'm going to place its electrons. Now, since it has 1 proton, that means for our purposes, so far we haven't learned the exception of this rule, it's also got 1 electron. So that first shell, I will label K, and I'm just going to put 1e here. That first shell can hold 2 electrons, but in this case, hydrogen only has 1 electron. All right? Okay, that was a weird one, so let's do one more. Helium, if I look at the periodic table, has a mass of 4. Atomic number is 2. So it's got 2 protons, 2 neutrons, and in its first shell, that's where I'm going to put its 2 electrons, because that first shell, K, can hold 2 electrons. All right, so I want you to take a look, see if maybe you can draw what you think maybe in pencil would be the Bohr diagrams of a couple more of these, and then we will go ahead and finish them up in class the next time that we meet.